Right now, ASTRA is hard at work building and testing Transcendence, which is our rocket which we're designing that will go to space. And probably the most important system in that rocket is the propulsion system, which is responsible for moving the rocket to space. But this can't happen without fuel.
I need fuel!
ASTRA has chosen a hybrid propulsion system in order to get us to the Kármán line, which means that we'll be using nitrous oxide as our oxidizer and paraffin wax as our fuel. So it seems like getting that fuel should be as simple as just buying some paraffin wax. But it turns out that it's actually a bit more complicated than that. So if it's not that simple, how is it that we go about making our fuel and getting it ready to be the fuel that we use on the rocket? Over the past few weeks, we've been specifically working on an apparatus which we'll use in order to manufacture our paraffin grain. In order for a hybrid rocket to work, the fuel needs to be in the shape of a cylinder with a hole drilled through the middle of it. And that hole needs to allow the nitrous oxide to, of course, pass through it and burn the fuel radially as the burn progresses. There can be other shapes you can construct with a hybrid system. However, what's necessary is there must be a hole that passes through it in order to allow the nitrous oxide to go through. But it just turns out that the cylindrical model is actually the simplest, so it's going to be the one that we're going to be working on today. Unfortunately, they don't exactly sell cored cylinders of paraffin wax in the diameters that we need to make our rocket work. So there's a little bit of manufacturing that we have to do on our own. In addition to this, the paraffin wax isn't actually the only component inside of our fuel. We're actually going to be using some additives in order to give the fuel some more structural rigidity and also enhance the burn rate properties that we see in the paraffin wax. So how do we go about building this test stand? The main goal for manufacturing our paraffin wax is actually to form that cylindrical shape. So we have to be a little bit clever about how we go about actually doing that. Probably the easiest way we could do this is just by simply pouring the paraffin wax into a cylinder and then maybe trying to cut a hole into the middle of it. Alternatively, we could actually pour the wax into a cylinder with like a cylinder of wood stuck in the middle that would kind of be the core, and then we could just pull that piece of wood out, and then we should have our perfect cylindrical shape. And while this would theoretically be maybe the easiest way to go about this, there actually are some underlying problems. The first issue is that when paraffin wax cools down, it actually shrinks quite a lot. Sometimes up to 20% of its volume is lost during that cooling process. This can be a problem for just pouring the paraffin wax into a mold because there can be gaps that form as the paraffin cools, which essentially could cause really big problems for your burn and potentially cause things like a Kato. So in order to overcome this challenge, it actually makes sense to try and maybe spin the paraffin wax grain as it cools so that you kind of are constantly distributing the paraffin wax and preventing those gaps from forming. Theoretically, we should have the cooler solidifying paraffin wax sinking and forming on the edges of the cylinder as it rotates, with the liquid part of the paraffin wax remaining inside of the middle. And then eventually, after waiting for all of the paraffin wax that's spinning to cool, you should have a perfectly formed cylinder with a hole in the middle. So the real trick to making this paraffin wax grain manufacturing assembly was just find a way to keep the paraffin wax spinning for a long duration of time so that we can have the full setting of the paraffin wax into the cylinder that we want. So to manufacture this apparatus, we simply put some wood together as a frame and then attached a grinder motor to one side of it. And then it was just a matter of trying to find an interface which would interface with the motor and the tube that we wanted to spin, and then finally the tube and the bearings that we wanted to use on the other end of the frame. This actually took a little bit longer than it should have because, you know, when you're fitting things and trying to figure stuff out, things come up. Our first idea was to just use wood for the entire stand, so actually use wood for the connections to the bearings and to the motor. But it turns out that wood is not exactly a super precise material to be using. Screws don't go in exactly straight, and it's tough to cut wood in exactly straight just because of the nature of its material. So it turned out that wasn't exactly the most secure solution to be using. So we had to actually switch to basically aluminum connections, and we had to kind of like redesign all of those interfaces. So that took us probably a week or two extra of work in order to get this stand working properly the way we wanted to. In addition to this, because the grinder motor actually spins at a really high RPM, like up to 2,000 or 3,000 RPM, and we don't want to be spinning our grain that fast, and I certainly don't trust the preciseness of our bearings and connections to allow for that high of a speed. We actually did do one test spin up to the full speed, and it didn't go so well. So basically, because of the little tiny inconsistencies in the manufacturing of that interface, there's some mass distributions that aren't exactly perfect. So basically, once this apparatus gets up to the natural frequency of that distribution, you have this big, huge problem with stability. So in order to overcome this issue, we decided to electrically augment the voltage that was coming through our line. And basically, that makes the motor spin at a lower rate. So we were finally able to get this thing working. We just had to do some electrical augmentation, courtesy of Anesh, who is an honorary propulsion engineer today. So Taha, how do you feel?
I feel great about coaching other team leaders for my team.
Perfect.
But yeah, something's moving, that's great.
Then for the fuel side of things, we basically bought a bunch of paraffin wax, a pot, a hot plate, and those additives that we're looking to put into the paraffin wax to hopefully enhance its mechanical properties. And these basically are going to help enhance the structural integrity of the paraffin wax. This is actually a really big issue for once we actually put the paraffin wax into a rocket, because there's going to be really a lot of thrust that's coming, and the whole grain is going to be under high G's of acceleration. So it needs to be able to be structurally strong enough to withstand those forces. So with all these pieces figured out, we were finally able to get outside and try to make one of these grains. Our plan was to manufacture a grain which is about 1/2 meter long with a mass of around 3 kilograms. So first we poured 2.9 kilograms of paraffin wax into the pot, and that was followed by about 60 grams of microsilicate, which is going to be the additive that we're using to give the paraffin wax more structural integrity. Then we put the pot onto the hot plate in order to heat up that paraffin wax so that it would liquefy. And our target was to get the paraffin wax up to about 80 degrees Celsius, because here it's definitely going to be a liquid, and it should have enough time so that we can put it into the tube without it solidifying, as we're doing it. While we waited for the paraffin wax to heat up, we decided to set up the stand. What we have here is the electronic speed limiter that we're going to use for the spinning stand. And basically what this does is it lowers the voltage that the motor will be drawing from the line, and that lowers the speed that the motor will rotate at. So yeah, we just have the input, which you connect to like the input line, and then you have the output, which connects to the motor, and that basically goes in between the motor and the wall. And there's one last part which is really important, and you should never forget this, which is to always make sure that your earth wire is connected properly. So because there's this, we have this metal cage here, this is a safety feature because there can be charge that builds up on this device, and you don't want to have a risk that someone touches this and it discharges and you could essentially electrocute yourself. So you want to connect a line that goes from this box here to the earthing line in your wall socket. Finally, after about 30 minutes of waiting for that pot to heat up, we were able to liquefy all of the paraffin wax and be ready to start pouring. To do this, we basically took that tube, took off the lid, and then we're able to pour the pot of paraffin wax into the tube that we had constructed to do the spinning. After this, you're kind of time limited, so it took all hands on deck in order to get that tube closed again and sealed. We just used duct tape because hey, duct tape fixes everything. And then we're able to connect the lid to the motor and then get the bearing on the end also connected and screwed into the frame. And just like that, we were ready to spin.
It's working! It's working!
So maybe you would expect that everything would be, smooth sailing from there, but it turns out that we ran into a lot of unexpected problems that maybe we should have expected. The first issue was an issue that, should be expected, which is heating. So because the paraffin wax goes into the tube so hot, the tube itself actually gets pretty hot, and we kind of wanted to make sure that we didn't damage the structural integrity of it because of that. So we came up with a plan to spray some water onto the tube as it was spinning, which actually worked out pretty well. We were able to keep the temperature of the tube to a relatively low temperature of between 30 and 40 degrees using this method. It should theoretically enhance the flux of heat through the tube itself.
Because you raise the temperature on the other side.
Next time we could build something that we have different holes instead of just pouring it a bit.
Yeah. It's like a PVC pipe with 5 holes.
Like a gardening sprinkler.
Yeah.
Wait, what? The second problem that propped up, which was a less expected problem, although in hindsight maybe we should have expected it, basically the motor that was spinning the tube actually also got really hot. And not just in the, tens of degrees, it went into the hundreds of degrees. So we had to actually stop the spinning and try to cool down the motor a little bit.
This means it's smoking? Yeah.
Oh no.
Yeah, I think we should keep this on. Like they're doing in a Formula 1.
Yes.
Did we kill our motor?
Yeah, and that I think
Possibly.
Out of here.
plot.
There is
Some magical blue
water,
smoke.
and then
And then we noticed that once we'd had the motor cooled down, we actually couldn't keep spinning using the motor at all, which was really weird. We thought we'd actually had broken the motor. But after a little bit of reflection, we realized, no, the motor wasn't broken. The moment of inertia of the tube has actually changed. So basically, when the tube is initially spinning, it's just the tube that's spinning, and the liquid paraffin inside of the tube is actually just sitting there. But basically, as the paraffin wax solidifies on the edges of the tube, that actually increases the moment of inertia the tube has, and that will increase the torque that's required in order to spin the tube. So in effect, the moment of inertia of the tube had gotten so high that it exceeded the torque the motor can produce at the start of its stall period. So essentially, we'd made the motor useless. Of course, in hindsight, we could have calculated this, but you know, sometimes things just don't seem obvious until you actually do them. So after this, we basically had to just manually spin the tube, which was perhaps a bit annoying, but not the end of the world.
Eventually.
Finally, we were pretty sure that the paraffin inside the tube had solidified, so it was time to open up the tube to see what's inside.
so let's do it all the way. Like this.
Good. Oh, you're disappointed.
Good. Just ease that off. Yeah.
Good. You want to use the color?
You fill the liquid?
Let's keep it here. All right, here's the tricky part. I'm going to.
Is it on camera?
Yep. I'm going to spin this.
Yep. Okay, that's all. Do it.
Oh, come on.
Oh! Oh boy.
Not
My God.
Well, it is a circle.
Jesus. Well, camera.
Wait, the temp gun. Where is it?
It's there. Upper na temperature gun. And measure it.
Huh.
Inside.
Interesting.
50 inside. 45.
44, 46, 29,
How solid is it?
This is weird. Okay, that's not what I was expecting. So what we realized is that actually the paraffin wax wasn't really smoothly going onto the walls of the tube, but instead had these like rough clumps that you see here in the picture. The reason for this seems to be associated with the cork that we used to insulate the tube, because all the places that we had the cork, we had this rough surface of paraffin that formed. However, on the surfaces that were not covered by cork, we actually saw a very smooth layer formed. So in the future, we probably want to not use cork as our material to insulate the tube. So we learned a lot from our first trial of spinning this paraffin wax. Unfortunately, it didn't quite go according to plan in all areas, so there are definitely some improvements that we'll need to make the next time if we want to have this happen successfully. First, we're going to need to upgrade the spinning stand so that we can actually have it automatically spin and not have to manually spin this thing for many, many hours. Because although that's possible, it's kind of annoying to be doing that all the time. This will probably need some sort of gear function, which will allow us to step up the torque of the motor so that we can keep spinning even when the moment of inertia of the whole system increases by quite a lot when the paraffin wax starts to cool. The second major change we're going to need to make is to actually not use the cork layer at all. It's quite clear that the cork was actually contributing to the clumping that we saw in the final product, so we think if we just get rid of the cork layer, that should basically solve that problem altogether. And then finally, one last change that we want to make is actually to the properties of the paraffin wax grain itself. We only used one additive in this particular example with the microsilicate that we had. In the future, we'd like to also add PE wax in order to continue to enhance the properties that the paraffin has. So with these improvements, we hope to be back to testing in a couple of weeks and hopefully successfully making a paraffin wax grain. If you want to continue following our progress, be sure to give a like and subscribe. And remember to expand your horizons.